Hi everyone. In today's challenge, we are going to solve this problem. The problem name is all node distance k in binary tree, and the problem number is 863. Alright. So first of all, guys, we are going to understand this problem statement. So first of all, we will understand the problem statement. After that, we will move to the logic part. We will see how we can solve this problem. What is the logic to solve this problem? And after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python and C++ programming language. And in this video, we are not going to implement with Java and JavaScript. Just the reason is video is going to be very long, right? But believe me, if you have seen the implementation of Python or C++, then you can easily implement in your programming language as well. Whether it could be JavaScript, Java, Ruby, any other programming language, right? So now guys, let's see what this problem says, right? So problem says, given the root of a binary tree, the value of a target node, given the root of a binary tree, the value of a target node and an integer k. So that means we are given three things. First is root of binary tree, and second is nothing but we can say target node, and third is nothing but we can say our integer, right? K, integer k. So these three things are given, and now what we have to do after these three, return an array of values of all node that have a distance of k from the target node. Simple thing, guys. So first thing is nothing but we can say root node, second is target node, and third is nothing but we can say k. Now what we have to do, we have to find all the nodes values which are at the k distance of this target node. And if you're not getting this, don't worry, let me show you with the examples. So here, and also one more thing, guys, you can return the answer in any order. Doesn't necessarily that the first it should be sorted or any other order. It can be in any order, right? So now let's understand this with examples so that you can have better understanding what we have to do. So we are going to see we have this three array, right? This array, that means nothing but this tree, right? So we are not given this actually array, we are given just three root node, this one, right? Now we are given this three root node. So let me write just three root node, and then we are given a target five node. This node of five value, this is node as well, right? So five node, and then we are given k is equal to 2. Fine. So this is nothing but integer k. So guys, now what we have to do, we have to find all the node value which are at the two distance, at a distance of 2 from this 5 node, right? I hope it makes sense. So if you can see in this particular image, so here you can see we have this 5 node, right? So we have to find all the nodes first of all which are at the distance of 2. So this is at the distance of 1, this is also at distance of 1, this is at distance 2, this is at distance 2, this is at distance 1, this is at distance 2, this is at distance 3, 3. So guys, here we can see that there are three nodes which are having a distance of 2, 1, 2, and this 3. These three nodes are at the distance of 2 from this 5 node. Now what we have to do, we have to return just their values. So 1, 7, and 4. There you can see we have given answer 7, 4, 1. So order does not matter. Even you write 7, 4, 1, 1, 7, 4, or 4, 1, 7. All are true, right? So that means nothing but we have to return this particular node value. I hope you understood the problem statement now. What we have to do, we are given three things. First is root of binary, second is the target node, third is nothing but integer k. Now we have to find all the nodes value which are at the k distance from our target node, right? Now let's see the second example. In the second example, we are given just a one binary tree, that is 1, and after that we are given a target node also. This is only the target node, and then we are given nothing but k is equal to 3. We have to find all the nodes values which are at the 3 distance from this target node. And if you will see, there is not a single node present with this particular node, right? So there is no more node present, so we can say there is no, so we are going to return 0, means nothing we are going to return, so it will be empty array, right? So that's all, guys. This was the simple problem statement. Now let's move to the logic part and see how we can solve this problem, right? So let me remove all these things. So there are many ways, guys, to solve this problem. The first way which we are going to use in Python is nothing but just going to implement one more pointer, and that will solve the problem. In second way, we are going to use C++. We are going to use a adjacent list, and then we are going to solve. But let's understand each in detail, right? How we are going to do this thing, so that you can understand in the implementation part. So guys, we are given this array, right? Not array, we can say this binary tree. So let me remove all this thing. Now guys, you can see we have given this thing. So we have 3, then we have 5, then we have 1, right? Then we have nothing but 6, then we have 2, then 7, then 4, then 0, and then 8. I hope you can see this particular thing, right? So once this is done, what we are going to do, we are going to say fine. For each node, we are currently storing left and right pointer, right? For 3, we are saying, that for 3, we can go to 5, we can go to 1, right? And for 5, we can go to 2, we can go to 6, right? Because 5 left is 2, 5 left is 6, and 5 right is 2, right? That makes sense, right? Isn't it? So once this is done, so we can say from any node we can go to the left side or right side, but we can go to the top of it. Why? Because we don't have that pointer, right? So you can see if once I go to this 5 node, right? I am, let's say I am here because this is given, so I am here, right? Currently I am here because this is already given to me, so I can easily go to this particular node. So I'm here, so I can say fine, I can find all the kth node distance from the left, we can say below of it. So if I consider this particular tree now, so I can find all the nodes which are having a kth distance, right? Which are having at a 2 distance below of it on this particular tree, right? Because this is one, this is two. Because I can easily go to this is one, this is two, right? So because I can easily move to this from, because there is a left node, there is a right node. From the I will come to this from right also I will come to this left and right. So I can easily get this. But the issue is, guys, there, how can I, let me remove this particular thing, how can I go to this particular node? Because this is also second distance, right? This is also at a 2 distance of this 5 node. So for moving to this, I need to go to the top, but there is no pointer present which can move to this 3 pointer. There is a pointer present left which can move to 6, there is a pointer present right which can move to 2, but there is no pointer present which can move to 3, so that I can come to 1. So we can say, guys, we are going to make a new pointer, that is nothing but we can say parent. We are going to make a new pointer parent which will help me to move to the top as well. Right. So let me show you how this is going to work. What is the benefit of having a parent? So what I'm going to say, guys, initially, I need to find all the nodes which are present at the 2 distance, right? So I'll say initially I'm at a 5, right? This is given to me, this node. Now I will say fine, this is 5, great. From 5, just check me, tell me, not check, just tell me how many nodes present at the first level. So 5 node, we can say this is the first, we can say 6, this is 2, because we can get from the left and right. But as if we have a parent pointer as well, so 5 will say there's one node present with me, that is 3, right? So this is nothing but these all nodes are present at the first level, means at the first distance, but we don't need at a one distance, we need at a two distance. So what we'll do, fine, now do one by one. From 6, just tell me how many nodes present to the first left, right and parent pointer. There's no node present, so it will be empty. From 2, yeah, there is a node present, there's 7, there's 4. From 3, yeah, there is also one node present, that is 1, and that is 5 as well. But believe me, not believe me, just note here that 5 is not going to count again because we have already counted it. So we'll make one set which say that don't allow that particular element which we have already taken, right? So we'll not take 5 again, right? So this is the, these are the 3 nodes which are present at the second level, and that are only the answer that you can see 7 4 1, 7 4 and 1. So this is nothing but the answer. I hope it makes sense, right? So what we are doing actually is we are making one more pointer, that is point parent, which is pointing to the parent of their particular node. So 5 parent is 3, 6 parent is 5, 2 parent is 5, 7 parent is 2. And after that, we are doing nothing but we are just saying that okay, this is one nothing but target node. From there, just start a BFS. And till what? Till level 2. Nothing else. Just start a BFS till level 2. I hope it makes sense. So it is easily going to solve this problem. I hope it makes sense, right? So this was the first approach where we are going to make a new pointer parent. So this will work easily with the Python. Right, now let's move to the second approach, which is adjacent list. And how that going to work, that also we can see. So let me write a second approach, which is nothing but adjacent list, right? So what I'm going to do, guys, we have a adjacent list. So initially we'll say there are how much pointer? 1. From 0 there are 6, right? From 0 there are 6. That's great, right? So for 0 initially there is nothing, for 1 nothing, 2 nothing, 3 nothing, 4 nothing, 5 nothing, right? So let me give a little space. 4 nothing, 5 nothing, 6 nothing, right? Now what we are going to do, initially all are going to be empty, but what we have to fill here, we have to fill their parents, right? Left, right and parent, as we do for node, right? So for 0, you can see for 0, this particular node, what is the parent? Parent is 1. What is the left child? Left child is null, so we can give a capital N, and right also null. For 1, what is the parent? Parent is 3. What is left? Left is nothing but we can say 0, right 8. And for 2, you can see, guys, parent is 5 and left is nothing but 7 and right is nothing but 4. For 3, where this is the root, so there is no parent, so parent is null, but left is 5, right is 1. For 4, you can see here parent is 2 and left is 7, but parent is 2, left is nothing but, let me write here, parent is 2 and left is null and right is also null. For 5, you can see parent is 3, left is 6 and right is 2. For 6, you can see for 6, where 6 is nothing, right? Parent is only 5 and rest nothing, none, right? Fine. So we have made this adjacent list. After that, what we are going to do, we are going to again do the same thing. We are going to insert 5 node at the top of it. We are going to use a BFSA. So from 5, just check in the adjacent list where we can move. We can move to 3, we can move to 6, we can move to 2. Let me change the color. So from 5, just you have to check this particular thing. So from 5, we can move to 3, we can move to 6, we can move to 2. It makes sense, right? So fine. And after that, okay, what I have done, just let me do this thing. Fine, it's working fine. So after that, what we are going to do, we are going to say fine. After 3, you have to check from 3 where we can move. We can move to 5, we can move to 1. We can move to 5, we can move to 1. But again, we are not going to take the same thing. So we will say no, 5 don't gonna come here. We can only move to the 1. From 6, where we can move 6 from, we can move to 5. Again, we can't do that particular part. 6 is going to be null because 5 is already taken and rest are null, so it's going to go in nowhere, right? And from 2, just check where you can move. From 2, you can see we can move to the 5 7 4. So 5 7 and 4. Fine, this is the second level. We are going to stop over here because this was the first level. So on second level, you can see 1 7 4 because 5 has already been taken. So 1 7 and 4. I hope it makes sense. 1 7 and 4. We are going to return this particular thing, and this is the only answer. So I hope guys you understood the two way. The first way using a parent node, parent pointer, just pointed to each node, and second is nothing but making an adjacent list and solving with this particular thing, right? So you can easily implement this in any programming language, whether it could be Java, JavaScript, or Ruby, or you can say Python as well, and C++ as well, right? So but we are going to implement this with C++. So now let's move to the implementation part. First of all, let's implement with Python, that parent approach. Then we are going to implement this particular approach with C++. Fine. So guys, I'm first of all with the Python. So here, first of all, we are going to implement that parent approach. So I'm going to make a add parent node function, and this node is going to take a one root node and that parent, right? And if root is null, that means if not root exists, right? So we are going to return, right? But if root exists, so we are going to say root dot parent should be equal to this parent node, right? And after that, we are going to say if, not if, we are going to call the same function add parent node for root left and add parent node for root right. Let me do a small. Fine. Once this is done, we are going to come out from this loop and we are going to say call this function first of all at parent node, and you are going to pass your root and you are going to pass your parent is nothing but initially none. Fine, this makes sense, right? After calling this function, we are going to say our q is going to be nothing but initially dq, and this is going to have nothing but we can say initially target, right? Fine, and in our set is visited, this is also going to be target initially, means we have already insert the target, we don't want to set it again. Fine, and we are going to have distance which initially 0, and we are going to say while distance is less than k, but before that let's check as well while our q also exists, means at least our q one element is present in our q, right? Now we are going to get the length is nothing but length of q, and here we're going to say 4 underscore in range of n go to this level, and in this level first of all take the pop left, means left part, so we can say data is going to be nothing but, or we can give a name node which is nothing but q dot pop left. Fine, once we go to node, what we are going to do, we are going to say fine, you go to node and you have to check whether we can move to the left side, right side, and the parent side or not, right? So we're going to say we have three possibilities for child. There are going to be three child for child in node dot left, node dot right, and node dot, we can say just give me a second, node dot parent, right? Fine. And in these three options, we have to check first of all if child is present, if child is not null, right? Child exists and child not in is visited. Fine, if child exists and child not in is visited, so what we are going to do, we are going to say fine, then you can insert in our queue, so we can say insert in our queue, so q dot append in this child, and also you have to say is visited dot add this child, we have to add this child in our set as well. Fine, after the once this is done, we are going to say come out from this loop, you can say distance is going to be nothing but plus equal to 1, and after that we going to say oh fine, we got this loop will over only when we reach to the our given level or our queue is empty. So if queue is empty, so we are going to return empty thing, right? So we can say we are directly returning a node dot value for node in our queue, right? So now let's run this code and see whether it's working fine or not. So we can say fine, let's call this function, let's see whether it's working fine or not. So we got a one error that is nothing but add parent root dot left, right? So all right, so we have to pass a parent here, right? So we are going to say parent is going to be nothing but itself root for left side. Fine, now let's run this code, and I hope guys it should work, right? You can see guys both that SKS pass. So let's try to submit this code, and it was a simple one guys, right? Just we need to keep a tag of parent, then do simple BFS. So you can see guys it successfully got submitted. Now let's move to the next programming language, which is nothing but C++. Here we are going to use a logic of adjacent list. So we are going to say let's create a vector, not vector, let's make an ordered map, right? And here we are going to say tree node, and here it's going to have a vector of tree node. right? And after that, once this is done, we are going to say in the name, I'm going to give adjacent list. Fine. And here we are going to call these functions where which is we are going to insert our data. So we can say adjacent, let's say uh, create adjacent, right? Create adjacent. And here in this function, we are going to pass our root node, target node, not target, we can say parent, so which initially null pointer, and then we are going to pass our adjacent list. Fine. And here in this above, we are going to define this function. We are going to say fine, let's define void create adjacent, and there we're going to have a tree node which is going to be root. Then we are going to have a parent node which is also going to be tree node parent, and here we are going to have nothing but adjacent list. So adjacent list is nothing but this unordered map. So we can copy this particular thing and we can paste it over here. Fine. So once this is done, we are going to say fine, we got this thing. Now we are going to check if agar root, if no root, so we can directly return, right? But if root exists, then what we are going to do, we are going to say adjacent list, and we have to use this adjacent list, and right here adjacent list with a password value, right? Fine. And adjacent list, what we are going to do here, adjacent list of this particular root, we're going to say push back. What first of all, push back parent. Then we are going to say fine, you have push back for parents, then you have to push for left side. So for root of left, then you have to push for right side, root right. Fine. Once this is done, then you are going to say fine, we are going to call this function again, create adjacent, and here we are going to say root is going to be now root of left, and parent is going to be root, and this is going to be same adjacent list, right? So copy this and paste it over here. There just you have to change for right. Right. Once you call this function get over, you will have your adjacent list, right? After that, what you're going to do, you're going to say fine, we got adjacent, we are going to use a BFS. So for that, we are going to make a queue of tree node, and this tree node is going to have a nothing but queue, right? And initially queue dot push, we have to push target, so we have to push our target. Then we are going to make a set, an order set. This is going to be tree node, and this is going to be named nothing but is visited, and is visited dot insert. You have to insert target, fine, initially, and after that you will have one more variable, that is distance, which initially 0. Now we are going to use a BFS while our queue is not empty, right? While queue dot empty, right? And we can say our that particular distance is less than k. Fine. Until unless this condition does not match, keep going, right? So once this is done, we are going to say fine. Let's say take a length in n is equal to nothing but queue dot size, and for int I is equal to 0, I less than n, I plus plus. Here we are going to say fine. If not, if we have to take a auto data node, we can say node is going to be nothing but q dot we can say front, and after that we can say simply q dot pop, and here we can say if now we have to move to the 4 side date, so we can create an array of tree node. Here we can say not array, we can say child. There are going to be 3 child, right? And instead of doing all these things, we have make a map, so we can say only for auto our child on what we can say adjacent list of this particular node, right? So now this will tell us that how many we can say node present for this particular child. So we have to say if child is not equal to null, if it is not equal to null ptr, and child does not exist in our set, so we can say is visited dot find, try to find this particular child. If it is equal to is visited dot end, then cool, right? So then only you can say fine, we have to insert this in our set, is visited dot insert this our child, and then you have to insert in our queue as well, queue dot push this particular child. Fine. And after this for loop, we are going to say increment our distance plus plus, and after that we are going to say this loop will come only out when either q will be empty or distance will be less than k. So we can say our result, let's create a result vector of int result, and in this we can say while our q is not empty, while q dot empty, so you have to say just q dot pop, and before popping the q value you have to say result dot push back and q dot front dot value. This will return the value, right? So once this is done, you are going to simply return this particular result. Let's see whether it's working fine or not. Simple thing, guys, what we have done. I hope you understood all these things. Simple done the VFS. So you can see both the test case passed. So let's try to submit this code as well. And if you are having still any kind of doubt in this code in C++, so let me just summarize this one. First of all, you can see, guys, this successfully got submitted, right? So what we have done, guys, first of all, we have created one function, create adjacent, right? So let me close this. So you can see, guys, we create a function, create adjacent. This function is calling first initially where we are making an adjacent list, right? So for each node, we are going to have the left node, right node, and the parent node. And after that, once we got adjacent, we are just using a BFS. And the starting node is nothing but our target node. So we have push target, and set is initially set is going to be empty, but target node is going to be inside the set, because we should not want to take target as well again. All right. After that, distance is 0. Means we want to take k. We want to reach to the k level, right? So while distance is less than k, keep moving, and q should also have at least one data. So we'll keep moving to all the childs, and we again keep moving, going so on unless distance is less than k, q is not empty. Once this condition does not match, so we'll come out from this loop. There could be two reasons. First reason could be either distance be equal to the k, or the queue become empty earlier. So we are going to say just until and unless queue is not empty. So take all the data, whatever present in queue, that will be our result. So if this queue got empty earlier, so it will be empty. So result is going to be nothing but empty array, right? So this is the only thing we are doing in the C++. I hope you understood this. If you have any kind of doubt, you can write in the comment section, right? So guys, finally, if you have any kind of doubt in problem understanding part, logic part, and the implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.